Hi everyone, welcome back to GameMaker Cast. In today's video, we're going to be adding the first enemy to our platformer. The enemy is very similar to the blockhead found in Super Mario. Now, I'm not going to be adding the animations in this video because I feel that if you followed the player state animations, then you should be able to do this yourself as they are pretty basic. However, I will cover that in a later video. This video is just going to be more focused on the AI of the enemy itself. So actually, let's get started by closing our game, and inside the sprites we're going to create a new group called enemies. And then within this group, let's create another group, and we're going to call this blocky block, as this is going to be the actual enemy for our game. Now, if I open up my folders here, you can see that I have an idle state here. You will be able to download these all on the Patreon page, but basically we're going to be using this idle sprite to do the information or the stuff we need to do in this video. So I need to import it into GameMaker. So the easiest way to do this is just do a click and drag it in here, and you can see it comes up. The only thing I'm going to do is change the name to SPR blocky block underscore idle, and then I need to make sure that the anchor is going to be in the middle, and I can check the collision mask. I want to use the full image itself. So we have that done, so let's make sure that we save it. The next step, we're going to make a new room, and what I'm going to do is duplicate the room that we have right here. And I'm just going to rename this to RM enemy, and I'm going to make sure that I drag it above the RM game. So you can see right here, this is just a little tip. When the highlighting is at the bottom, you're dragging it underneath. If your highlighting is over on the right, it's going to try and make it a child. So you want to make sure that the highlighting is on the top. Then it will make sure it moves it to the top. Now, we're going to leave this up because we are going to come back to this. And the reason why I'm really just doing this is because I don't want to lose any of the settings that I've already made. So we are going to go to objects, and let's create a new group here, and once again we'll call the group enemies, and let's create a new object called obj enemy, and then blocky block. And for now we will assign the only sprite that we have, which is going to be the idle sprite. And back in our room, we're going to take this guy and add him to a new instances layer. So we'll create a new layer and call it enemies. And what we're going to do is take him and let's just put him at the top here. So how he's going to work is when the player comes close or within a certain radius, he's going to see that and he's going to slam down on the ground. He's going to find the floor, so slam down on the ground, then wait, let's say a couple seconds, and then he's going to come back up. So he's going to hope to squish the enemy itself. So I'm going to close my room here, and now we're going to get started on some of the code. So just like before, we're going to be using a state machine, so that means I'm going to need to add some new states into my state script that I have. So in scripts, I have the state script, so I'm going to open that up. And then in here, we're going to add a new enumerator, and I'm going to call this enumerator enemy blocky block state. So in here, we are going to have a couple different states. We will have the idle state, a falling state, the waiting state, and then finally the retracting state. So going back up. I think that's the only four that I need. We may have to come back to this. Okay, so let's close this and then open up our new enemy block. We're going to add a create event. We will need a draw event just to do some debugging. And finally, we are going to use a step event. So we will actually go to the create event first, and I want to pull this over here. And we're going to have to talk about kind of what we need. So we're going to be using basic physics to help this guy move up and down. So that means that we need a gravity variable, and let's set this at something like 0.75. We also need to keep track of our vertical speed, which I'll set at 0. Now we are also going to need to know the original position that we are in. So there's a couple different ways that we can do this. Basically, I'm saying the original position because I, as the level designer, I'm always going to put him at the top of whatever I want him to be sitting at. So if there was a ledge right here, I would make sure he is up against that ledge. Now the other way we could do it is we could look for the ceiling and then snap him to the ceiling in code, but I find this way is just going to be a lot easier. So what we'll do is we will have a variable for the original position, so we could say y position original, and that's just going to be equal to our current y position, so wherever we are on the map. Then we also need a timer because one of our states is going to be a waiting state. So we'll say waiting timer, and let's just call this primary, and it will be room speed times 2, which will give us 2 seconds at whatever our current room speed is set for. So he's going to wait 2 seconds. The next thing we need is a timer to actually count down, because I don't want to have to go into the step event and change the timer if I feel 2 seconds is too long. I want to make sure that I change the variable within the create event, so then it just kind of filters through. So the next variable I will actually have is the timer itself, and I'm going to set it to the primary timer. So it's the actual waiting time will be 2 seconds, and then this timer is the one we are going to be counting down. Now for detecting where the player can be, we need to draw a bounding box from our enemy to wherever the solid object is. I could easily use a variable and say, you know what, the box is going to come down to roughly 640 pixels on the Y position all the way up to my current position, and that could be used as the box to check for the player. However, I think it'd be nice to know where the solid object is, so I don't have to kind of figure out where the variable is. So if I put him here, so I don't have to figure out where the variable is. So if I put him, let's say right here, he will automatically detect that the floor is going to be right here, so he knows that he can go down that far, and I don't have to kind of check with the variables. It just handles it automatically. So I think that'd be nice to do. So I'm going to create a new variable called y position floor, and for now I'll set it to 0. We will come back and we will fix up a function to do this. The final thing that I need is a state or a variable to keep track of what state I'm in. So I will use enemy blocky block state, and I will just set it to idle, meaning he's just going to sit there. So let's kind of switch gears and go over to the step event, because we're going to have to work on some of our AI. We need to use, well, we don't have to use, but we will use a switch statement here. So we're going to switch based on what state our our enemy is in. So we want to check to see if we are in the idle state. I'm just going to copy and paste this 3 times. So we have idle, then we have falling, we have a waiting state, and then we have a retracting state. So once we have these 4 different states, what do we need to do? Well, in the idle state, we are basically waiting for the player, and then we're detecting if the player basically comes into range. On the falling state, all we have to do is try and fall on player, and we need to detect if we hit the player, and then we also need to detect if we hit the floor, which is a solid object. While we're waiting, this is a simple one. We just say wait on the ground. If I could spell on the wait on the ground for X amount of seconds. And then finally, the retracting state is very simple. All we need to do is move back up to the original position. All right, so with that done, we can kind of work on a few things. We're going to start out with the idle state. So this is going to be the big one right here, detecting if the player comes into range. And if you remember at the start, we had this position of the floor. So we're going to use that to figure out where to draw the bounding box. And we're also going to draw it in the draw event just so you can see how it happens. So in here, we'll say figure out where the closest solid object is below me, so below our enemy. And let me actually close the room so we have a little bit more room to work with. Okay, so we need to use a collision list line. So if we type that in, we'll say collision line list, and we can check out the help on this. So basically what it's going to do is it's going to draw a line from the X and Y position to the X and Y position that we give it. And it's going to check for any of the objects that we tell it to, and it's going to return a DS list. Now, if it can't find anything, it's going to return the number 0. Now, the one thing that is nice with this list is we can tell whether or not it's going to be ordered by distance. So this will give us a quick access into the first element of the closest solid object. So the very first thing we need to do is define a DS list, and I'm going to call it DS instances. So we'll say DS list create, and if you don't understand the lists and stuff, that's fine. You can just follow along. Well, it's pretty simple here. So once we create a list, we will say var solid objects, and we are going to call the collision line list, and we're going to pass in the X position and the Y position. So this is going to be the anchor point on our object, so right in the center, and we don't want to move left or right, so again X, and then we'll say Y plus 1,000. So basically what I'm doing is with this enemy, I'm going down 1,000 lines, and I'm going to detect any of these solid objects. You don't really have to do 1,000. I could probably get away with 768, but that just really depends on how, or it should be the biggest space that you're going to have between the blocky block and the solid object. So back where we were, I am doing the Y position plus 1,000, and I want to make sure that I check for the object underscore solid. I do not need precision collision, so I'm just going to use the bounding box. I do not care if the variable calling is in this collision list, and now we have to pass it this list. So this is going to be DS instances, and finally whether or not it should be ordered. So with that amount of code, we should be able to check to see if we have any solid objects. So we could say if solid objects is bigger than 0. Otherwise, let's actually show debug message, and let's say warning, no solid object for blocky block. So if we don't find any object solid, we're going to throw just a debug message in here saying that there is no solid object basically found. Now, if we do have some solid objects, then we need to grab the first one, and then we're going to store the position of that first one into the floor position here. So the easiest thing for us to do is say that the Y position of the floor is going to be equal to the list itself, so the DS instance, and then we're going to access the first element in the list. And then once we're done with everything, we'll say DS list, and we want to destroy the list itself. And the reason we need to destroy it is because even though we created it and we used var here, it still remains in memory until we have destroyed it. So with this little code done, we should be able to save our project, go over to the draw event, and kind of draw some debug lines here. So we want to make sure that we draw self, so we're going to draw our enemy, and then let's do a draw rectangle, and we'll say X minus 64 at the Y position, X plus 64, and then we want Y underscore position floor, and we'll say that, it is going to be an outline, and let's actually say draw set color, and we want the color to be C underscore lime for a nice debug color. So all I'm doing here is drawing a rectangle located in the middle, 64 pixels to the left, 64 pixels to the right, and then down to hopefully where the position of the floor is. So let's run this and see what kind of errors we have. And you can see right now we're going way down, so our collision isn't being detected too well here. So if we take a look at our code and I go to the create event, I can see right here on this line I am assigning the Y position of floor the instant itself, and what I actually need to assign is the Y position. So with that fix, let's run it again, and we should see that our collision box is going to come down here to the very end. So this is the collision box that our blocky block can use. So when our player enters this box, he is going to get upset and he's going to fall down, and then wait right here on the bottom and then retract all the way up. So to do this, we'll go into the step event, and right here in the idle animation, we're going to put our collision code right here. Now we can get away with not really creating any list or anything, any real difficult code here, because we only have one player. So we could just say if the collision, and we're going to use the collision rectangle at our current position minus 64 and our current Y position, and then X plus 64. And then finally the position of the floor, if we have an object player, which is this guy here, if he comes into this box, and we will not use precision, and we do not care about the calling object. So once again, if the player comes in to this rectangle, then we know that we have detected the player, and we can say our state is now going to equal the enemy blocky block state falling. So once we do that, we can come down here. So we need to do a couple things. The first thing we're going to do is try and fall on the player. So this is where we need that little bit of physics to have our enemy kind of fall down. So the first thing we're going to do is we are going to say our vertical speed is going to be plus equal whatever we set our gravity to. And now we've already done this with our player. We're basically checking to see if a solid object is underneath us. If it is, then we will move close to it and set our vertical speed to 0. So once again, we could just say if the place underscore meeting of our X, Y position plus the vertical speed, so however fast we're moving, is going to intersect with an object solid, then we want to come in here and we will say while there is not a place meeting, so while it is empty at the X plus Y plus the sign of vertical speed for an object solid. And if you're not familiar with the while statement here, we're basically checking one space above or below. In our case, it's going to be below. So 1 pixel below for object solid. And if it does not exist, then what we want to do is move our character 1 pixel in whatever direction we are going, up or down. So sign will either be -1, 0, or 1. All we need to do is set our vertical speed to 0, so we know that we are now on the floor, and once we are on the floor, we can switch states. So we can say if the vertical speed equals 0, then basically we want to set our waiting timer to be waiting timer primary, just in case it is not, and then we'll say state equals enemy blocky block state dot waiting. Now in here, we will skip these for now. This we've already done, so let's actually move this up. And let's see, we have an error here because I'm missing a 0. And now let's go to the waiting state. So we have to wait on the ground for X amount of seconds. So this is pretty easy. We could just say the waiting timer minus equals 1, and then if the waiting timer is less or equal to 0, then well, all we have to do is change states. So we'll say state equals enemy blocky block state dot retract. And finally, the last state, all we need to do is move up to the original position. Now we could kind of do something like we did here with the falling and just reverse it, but I'm actually going to kind of skip all of that and just use the lerp function. So I could say our current Y position equals lerp of the current Y position, and I want to go to the position original, so move my character or move the enemy, we'll say 2% each frame, so he'll go up. And then all we need to do is check to see if we are back in the original position, which will set us to the idle state. So we can say if the Y position equals Y position underscore original, then we know that our state can now be the enemy state, or sorry, the blocky block state of idle. All right, so we did a bunch of code there. I think the only thing I want to do is after I draw the blocky block, I'm going to draw set color, not set circle precision. I'm going to draw that, and I'm going to use C white just to ensure it's white, and then I'm going to draw the text on the X and Y position of the current state. Okay, so that was a lot of code. Let's hit F5 and see how we did. Now, he should be waiting up top. If I come into this green box, hopefully he will come down. Well, his state did change, but he did not come down. So we have to figure out why he didn't come down at all. So we come down here, and the state is definitely falling. And let's see here. The only thing that I didn't do is I didn't assign the Y position to the vertical speed. And actually what I'm going to do is when he is waiting for the player, I'm going to ensure my vertical speed is set to 0, even though we do set it here just in case. So once we do all of this code, I need to say y plus equals vertical speed. Okay, so let's try this again. That was a minor error. All right, so let's try and walk into this box. He comes down, he gets hit, and back he goes. All right, that's actually not bad. Now, the only thing that didn't happen is you can see he's still in that 3 state. Now, do you know why that might be? And it's all to do with the lerp function. Here, if I change this draw event to be the Y position, I'm going to run the game, and you'll see what lerp is actually doing here. So once I come in here, you know the original position is 64. So he comes down, and then he'll go back up. But you'll see that now we have a floating precision here. So we have 64.00. So what we can do, we can use a little bit of math, and all we have to do is we can either floor it or we can round it. It really doesn't matter in this case because we just want to get back to the whole number of 64. So once it comes back up, you'll see it's 64, and all we have to do is take that little bit of code, which is the flooring, and go over to the step event, and right here where we're checking to see if this position equals that position, we'll just set the floor to that position. Now the only thing that we might want to do is floor this position as well, just so that they can be equal to one another. So that if this one is on a decimal place, we're going to have to floor both of them. So let's just try this enemy and see how he works. So he's at state 0, he'll come down, hit the floor, he'll wait 2 seconds, and then go back and set back to 0. So that's actually not too bad. And you can see that we can walk underneath, and as soon as I go in that box, he comes down and tries to hit us. Now this should be set up so I can place multiple blocky blocks within the room. Now the one thing that you'll want to make sure how we designed it is he is going to draw a line from the middle here and try and hit a solid object. So if I move him over here, even though, actually I guess that's a bad example, I'll have to put my grid down to 16 here. So if I move him over 1, you and I know that he's going to hit here, but what he's actually going to do is draw a line from the middle, and he's probably going to detect the floor right there. So let's actually see what happens. And you can see that the floor has been detected here, so even though I do that, he's going to hit right there, but the detection is going to happen here. So that's just one thing to keep in mind as well. But you can see that they're all working pretty good. And our AI is pretty much done. So that's just one thing to keep in mind when you're doing that, where he's going to throw out that line. So if I actually move him over a little bit, and I hit F5, the detection is going to be right up here. So it's not going to have any effect if my player is down here. All right, so I think that is going to be good for now. The next video we'll probably have him, we'll finish these the states, so we'll hopefully get him to interact with the player and possibly do the animations. I know this was a long video. I'd like to thank you for watching it and sticking with me till the end. I would like to thank my Patreon supporters, Matt and Paul, and the anonymous supporters that I have. If you find this video useful, please like and share it with others. Anything really to get the word out. Please subscribe on YouTube and check out the Patreon channel where you can find links to other tutorials and the artwork specifically for this video. Once again, thank you for watching.